Alright, so guys, we got to do concavity in the second derivative test. It's just like the first derivative. Alright, if the first derivative is positive, the function is going up. If it's negative, it's going down. If the second derivative is positive, the graph's concave up. If it's negative, it's concave down.
That's second.
Second derivative, right? Second. Test for concavity. Right here, if the second derivative is greater than 0 for all x in an interval, the graph's concave up. Then the question, though, Bailey, always right into the confusion here is what makes something concave up? Terry, I already heard how you explained about it. Is concave up is curled up like that, right? It could also be like that. You could be increasing concave up, you could be decreasing concave up. Terry?
So, like, let's say like a cup, if it was to, or we're able to hold water, like,
Just
say,
still what I was going to say, Terry.
Alright, so then by the same token, concave down is something like this, right? It's curved down.
like an umbrella.
And it wouldn't hold up. And then a point of inflection is where something changes concavity. That's where the second derivative is 0 or undefined. So if the second derivative is 0 or it doesn't exist, you have a point of inflection. And much like maximums and minimums are where the first derivative is 0 or undefined. Alright, so second derivative positive, concave up, negative, concave down. If it equals 0, it could have a point of inflection. So here's the perfect example right here. Can we figure out, list the intervals where this graph is concave up or concave down? Of course we can.
So do we need to pick the same derivative?
I concur with that statement. Huh? That was Christian confirmation. The cure. That was differential equations. Programming? Oh, MATLAB. So Terry, what's the first derivative?
First derivative, say 4x cubed minus 36x squared plus 96x minus 2.
So if we follow that, then the second derivative would be 12x squared minus 72x plus 96. So just, question? Oh. You look like you're about to ask a question. So just like defined where we had maximums and minimums, where a graph was increasing or decreasing, we took the first derivative, set it equal to 0. Here we want to take the second derivative, set it equal to 0. And I got a feeling 12 goes into all these numbers. They give us x squared minus 6x plus 8. Are there two numbers you can multiply to get 8 and add to get negative 6? Come on, Terry. So our possible points of inflection are 2 and 4. So now we want to test those. We want to get intervals. You know, if we start out negative infinity, come down to the upper line, we'll get the 2 first. Then we'll go from 2 to 4, then 4 to infinity. So we want to see what numbers in those intervals do to the second derivative. So some number less than 2. I think 0 is the easiest one. It's nice right here where we have it factored. You know, this really has a 12 in front of it, but that's not going to matter, right? So if we test into this right here, put 0 there, we get a negative times a negative. Terry says makes a positive. Between 2 and 4, we can pick 3. 3 minus 4 is negative, 3 minus 2 is positive. Negative times a positive makes a negative. Bigger than 4 will give positive, and positive makes a positive. So this thing is concave down from 2 to 4. And it's concave up from negative infinity to 2, and then again 4 to infinity. I think it just asked where it's concave up or concave down. But I like what you're saying, Terry, we could go further, right? If we want to point some inflection, there's one when x is 2. So then what we have to do is go back to the original function, plug in 2 to find the y. Okay. Remember, these are intervals here, they're not points. So that's not an x and a y, those are x's. Bailey.
So, what exactly is the point of inflection?
It's where a graph changes concavity. So watch, if we looked at this graph, so if we looked at x to the 4th minus 12x cubed plus 48x squared minus 64x. I'll go back to Zoom 6, the standard graph. I can't really see, but if you sort of look at it, see how this sort of looks like it's concave down, then it goes concave up. So that means there's a point of inflection there, and that looks like it's about at 4. There was another one at 2. If I go to the window, maybe let this go down further, maybe to negative 40 for y. Oh, I just go to negative 2. It's concave up, and then somewhere around here it turns to concave down. So those are points of inflection. We could actually figure it out. We can go to calculate here, calculate the value when x is 2. So at that point right there, it changed from concave up to concave down. You see, it was going concave up until we got to 2, and from 2 to 4, it's concave down. So at that point, it changed from concave up to concave down, and then at 4, it changed back to concave up.